Welcome and ahoy. Let's kick off the meeting by our switching skill on Lwig to transfer to globally.
I can see you speak clearly to the microphone, so I said remote participants.
So yeah, welcome. So let's kick off the meeting. I think
Is it on?
switch may be on there.
It's maybe the mic is switch on.
Okay, I see. Okay, sorry about it. So let's kick off the meeting. So this is a new version of the Note well. It's very important to be aware of this for any IETF meetings. And thanks for Mohit for the to be the minutes takers, and he's going to edit our notes on the Etherpad. And okay, we also have some. Okay, great. Oh, HBS. Okay. Sorry about that. Another port number. Okay, I will change this anyway. I think it's on the agenda anyway. So Yara is coming. So we also have a GitHub page for our working group with the our draft. So this is some updates of our status of the working group right now. So we have the energy efficient draft, which is in AD's hand right now. So Oral Switch is not here right now. So I think he's catching up with, oh, Switch is coming. So I already started. Okay. So we have on the agenda, we missed 2 milestones right now, including the crypto draft and the crypto draft and the co-app draft. So, but yes, I think we do need some good pushers of these drafts in order to get it done to be submitted to the IESG. I personally read the co-op draft again. I think it's pretty good draft. But anyway, we need somebody to make some edits before I can ship it to the IESG. And we have some green ones which will be discussed today, which is the TCP draft and also TCP guidance draft and also the ESP guidance draft. So, sure.
Suresh Krishnan as AD. So the energy efficient stuff just came into me like a couple of weeks ago. It's been, I requested an IETF review of this, so they're taking a look at it. So hopefully we'll get a review for that. And there's also an in-depth review going out. So like once that is done, I'll do my AD eval and send it to IETF last call. Okay. So hopefully like in a month and a half, it'll be in front of the IESG. Okay.
Okay. Thank you, Suresh. Here's our agenda. So we'll talk about basically, so the first 3 drafts will be within our current working charter, and we are going to discuss it. And the main object of the meeting today will be ask for adoption and for further steps of this draft. And for the last one on the agenda is going to be ask for the interest of the draft. So how to get inputs for our group. So any question regarding the agenda? Okay, pretty good. So I can move to the first presentation. So, yes. This one. The color is
The color is
strange.
not from me. So basically, this draft is providing some recommendation on how to secure machine-to-machine communication with IPsec ESP. And ISP is believed to, well, IPsec ESP is believed to present some significant advantages for small devices, especially regarding interoperability, VPN, it's transport layer independent, it's key management independent, and it has a lower overhead than TLS. The presentation has already been made in Berlin in the IETF 96 during the 6th law. Motivation remains the same. And so the problem is that the standard ESP is likely to be implemented by many different small devices. And well, this document is intended to make sure that this new implementation, light implementation, still be compatible with the standard one. So basically, we describe what are the mandatory features, as well as where other features, how they can be implemented in light ways depending on the context and the use of those. So overall, we already have a minimal IKV2 in this working group, so this document is continuing the effort for ESP. So we had a presentation during the Berlin meeting, and the document was believed to need more reviews from the IPsec working group. So we had, I think it was last IETF, a full session, not a full session, but a good review of the document, and we received a significant amount of feedbacks. So now we think it's relatively mature, which doesn't mean that we expect a few more reviews and process and back and forth. The document is clearly handled between the two groups, so it's not that we're trying to hide the document and the updates from IPsec ME. They're still heavily involved, and we're going to require them to review in detail the document. So what are the changes since the last version? So we really spent some time clarifying the purpose of minimal implementation. From the presentation, it was thought that we were designing a ESPv2, which is not the case. So it is the 2 bis. So we clarified the text on the SPI, so we detailed on how it can be handled with multicast or anycast communications. We detailed in detail how we can use a fixed value for ASPI or a limited number of values for ASPI in case of some devices could hardly generate a random SPI. We also clarified that it doesn't mean that you don't need randomness, because for crypto you need randomness. So it's just a way to avoid generating new SPIs. We clarify the padding. So padding was corrected. I mean, I think it was a wrong statement. And we clearly mentioned it as mandatory. And we also clarify with, ESP got some mechanisms so that you can provide some additional padding so that you don't leak any information about the size of the packet. So, well, for a minimal version, we clearly mentioned that these kind of features are not mandatory or not expected to be part of such implementation. Next header, well, we clarified the meaning of the next header, and also define that that was a missing part in the last version, that you have to remove to be able to discard some dummy packets. ICV, well, it was mostly a clarification, because the text was suggesting you can cut some part of the ICV or make some ICV optional, which was really not the case. So that has been clarified in the current version. And that's about all we did. We received some additional comments we will address in a further version. And we would like to continue this draft, I mean, in this working group, but in collaboration with IPsec-ME. We have, well, there are some known implementations, user-learned library in C, Python, and we have some support in Kentucky, Riot, and you will see later an implementation of this minimal hike for group. Sorry?
I didn't answer for which.
For a group key. So at the end of this session. So this is where we are, and we would like to move that work forward.
Can you say a little bit more about the implementations? Like there's Python implementation that hardly is for IoT devices, but
Yeah, that was mostly for testing the specs and testing the interoperability with.
So which of the
ISP?
The IoT OSs implement that?
So we have one in Kentucky.
Okay.
And I have heard that some in Riot are.
Tobias from LMU. The implementation for Kentucky is very old. That's done, I think, 2012 by Shahid Raza and his group. And we are currently developing one in Riot.
So Hannes again, so I think we should not do that work. It's a terrible idea. IPsec provides no benefits. The motivation that you presented there is just nonsense. It will, if people actually use it, it will actually add another security mechanisms that people then have to support, which adds fragmentation. I think it's a terrible idea. It doesn't do us a service. It's just bad.
So this is an opinion, but we have a few vendors that are quite interested in using IPsec. So
one of the good things about using IPsec is that you can actually also use the IC version 2 to generate the keys for the 15.4 layer, which you can't use the TLS because 15.9 doesn't support TLS because there was nobody to write the drafts for that. So that for if you want to have one crypto algorithm and one crypto protocol, you're gonna have IC version 2 and ESP and nothing else. You don't need TLS at that point. So, but actually, I guess in most of the cases in this kind of constraint devices, you pick one and you talk to whatever is your cloud or whatever service you have there. So if you use TLS, you use TLS everywhere and you don't support this. If you use IPsec, you use IPsec everywhere and you don't support TLS. So it's whatever you pick and you pick what is suitable for your needs.
Wait there. So are you implementing IC and IPsec for the 15.4 and this type of stuff in your products?
As I don't work anywhere now, I don't implement anything. But anyway, so 15.4 has a couple of algorithms that allows you to generate the pairwise keys, and IC version 1 is one of those.
Is that the 15? So I'm not totally familiar with some of the that IEEE work, but is that the IEEE work where they basically standardized HIP as a key management banner, or everything you can imagine?
Everything except TLS.
Okay. So are you guys going to use this in your products, in your like we are making things up a little bit?
well, we know some customers that are gonna use that. Yes.
Are you, Ericsson, going to use this stuff in your IoT devices?
I can probably detail what we're going to implement.
If Daniel wants to answer that question.
Well, I don't think I'm here to detail what is the roadmap for Ericsson as a vendor. So
I'm not asking for a roadmap, but we are standardizing something. We are providing implementation guidance. So presumably you've done something.
we working
I
on-
prefer to standardize something as guidance from implementations that has actually been done, rather than something that we may or may not do.
Suresh Krishnan. So Hannes, just hold on a second. The thing is, like, it's like an early individual draft, right? At some point, he's going to go for an implementation. I understand, right? Like nobody's requiring implementation for adoption. It's a good thing to have, right? So if I understand you correctly, your question should be, right? Maybe I'm paraphrasing. It's like, why do you see a need for this? Is that the right way to put it? Okay. So he's saying he has a need for it, right? Like, and we're trying to figure out if somebody else has a need for it. I think that's where he's at. So if somebody's trying to see a need for it, then we'll go forward. If not, like, this whole discussion is moot, right? We just move on, right? Say, Daniel, go away, and that's it, right? So I fully agree with your point. At some point, we need an implementation. Like, as a personal draft, I don't know. I think it's a bit early for that.
Anyway, he's not trying to standardize anything new. This is standard ESP. It's already standardized. It has been out there for a long time. He's just describing what kind of tricks and things you can do to make it very small, so you don't have to implement it, you don't have to read the whole ESP. And this is the same thing we did with minimal IKE. I mean, IKE was already published at that point, but the problem was it was 150 pages or more than 100 pages, and had all kind of features that you don't need. You don't need NAT traversal, and you don't need that kind of things and so on. In most of the minimal cases, you don't need those. So we were actually documenting just what we don't need. This is the same thing in ESP.
Hannes, again, I think also it was a bad idea to standardize this minimal IKE. And the reason is, whether some feature is really useful or not depends on what your environment is. Like the NAT traversal, if you talk to, like previously mentioned, you talk to some cloud service, probably you will have NAT traversal, and so on. So you just stripped out sort of random things. And basically, if I remember correctly, it was you focused on the BSK version. Of course, that gets the code size small, but that may be a right thing to do in some deployments, in some use cases, and not in others. We never had any experience with those use cases, and that's why it feels arbitrary.
For example, the 15.4 or 15.9 IKE version 2 is using the minimal one because it doesn't need NAT traversal because it's pairwise keys between two devices. It actually doesn't need most of the features of IKE version 2. It just uses the key generation, key management. So yes, there is uses, and yes, this will fragment the environment, but that will happen anyway, and it's actually already happening because I mean there is thousands of implementations using their own proprietary stuff, and as long as they use anything from here, it's much better than proprietary. And if their proprietary requirements are that they need to be sending IP packet, they don't want to do TLS, they don't want to do anything like that, this might be suiting better for them than the TLS. If it doesn't, they use the TLS. It's when they are making their product, they will decide what they are going to use. I don't think it's our point of view say, oh, you must not use this, or because they will use anyway what they have, what they want. Yeah, I know.
So Hannes, first, I think when we shepherd the minimal IKE document, we ask for your opinion, and you said it's a good document. We should shepherd it as soon as possible. I mean, when we shepherd the minimal IKE document, we ask for your opinion, and I think I still remember the email you sent. You said we should publish it as soon as possible. Okay. And secondly, for currently even for the RFC 407825, right? 25. So for the minimal IKE DOM, it's nothing normative, right? It's nothing normative. It's informational. So it tells people how to implement a minimal client of the IKE in a protocol in a protocol compliance way.
Mohit, so I don't want to continue this discussion. I just had a suggestion. So RFC 7942 lays out guidelines on how to improve awareness of implementation. So since you do have some implementations, it would be good to have a section documenting them, which of them are open source, where I can get them, and so on. That would
Okay.
definitely help. So now I go at the draft, and I don't know about the implementations.
Okay, right. Yeah, that's something that can be easily added.
So Daniel, there's one thing I'm not clear right now. So because you say that you want to continue to have this document in Lwig as well as IPsec-ME, so does that mean that you don't want to ask for code option today?
No, I want to ask for adoption today.
Okay. So let's see how. So because of the Hanny's comments, I think we should first ask questions like this. So how many people think that this is the question this is the valuable question we want to solve in this working group? Please raise your hands. So if you think that this is the right problem that we need to solve in Lwig working group, please raise your hand. Like 10. So if you don't think that, or if you don't think that this is the right play, this is the right problem we need to solve in Lwig, please raise it. So hands. Okay, we will take.
Take it on the minutes,
Oh
yeah.
yes.
So let the minutes note that Hannah saw us in the rough in the room.
Mm.
Hannah saw us in the rough in the room.
How many were yes?
Doesn't matter, like
Okay.
10,
Yeah.
more than 10 people.
Okay, then we'll take 3. Thank you.
No, everything is green.
Yeah, that's why. Here is okay. I think it's something. Oh, it's
It's VGA
It's
cable.
VGA. What's
I thought it's some like flashy like slides that he used.
Okay. Hello, good afternoon. My name is Carlos Gomez, and I'm going to present the last update of the draft entitled TCP over constrained node networks. By the way, we are pleased to have Michael Scharf as a new member of the author team, and would like to thank him for the contributions that he has already made so far. So first of all, a quick reminder on the motivation for this document. So nowadays we have several application layer protocols that are being used for IoT scenarios. For example, we have the constrained application protocol CoAP, which was originally designed over UDP. However, there's also an ongoing CoAP over TCP specification in progress that's mostly motivated by the need to overcome problems with middle boxes that appear not to be very friendly to UDP traffic. Also, we have that HTTP2 and even HTTP 1.1 have been used and are being used in some IoT scenarios. And then we have other application layer protocols such as XMPP or MQTT, especially the last one is very popular, which rely also on TCP at the transport layer. So we have that despite that TCP has been quite neglected and even unfairly criticized as a protocol for the IoT, TCP is being used and will be used in many IoT scenarios. So the purpose of this document is to offer simple measures for suitable TCP implementation and operation over constrained node networks. So let's look at the status of the draft. The initial version was presented in Berlin 1 year ago in both Lwig and TCPM sessions. Then the document was subsequently updated. There was updates 01 and 02, which were presented in Seoul and in Chicago, respectively. And today I'm presenting the last update, which is 03, where we have addressed comments received in Chicago, and also we provide details on the Riot and OpenWSN TCP implementations. By the way, thanks to Simon Brumer and Xavi Vilajosana for kindly providing details on these two implementations. Just a quick note to say thanks to everyone who has provided comments and feedback and input for this draft since the initial version. So thanks a lot, everyone. So let's go through the updates in this last revision of the draft. The first update is in the subsection entitled Maximum Segment Size. There was a related discussion in Chicago about nodes that use technologies that support an MTU which is greater than 1280 bytes. According to RFC 1981, those nodes should support PathMTU discovery. By the way, there's a note in that RFC that states that a minimal IPv6 implementation may choose to omit implementing PathMTU discovery. And the update in the document, also based on the comments received in Chicago, is that unless applications require handling large data units, that meaning leading to an IPv6 datagram size greater than 1280 bytes, it is desirable to limit the MTU to 1280 bytes. And by doing this, we avoid MTU issues along the end-to-end path, and also we avoid the need to support PathMTU discovery. So another update is in subsection 4.8, which is about delayed acknowledgements. So we have that a constrained device will be in some scenarios sending data to some peer, and the peer may not be a constrained device. So we may recommend, we can be giving guidance for constrained devices, but a problem is that sometimes the peer device will not be a constrained device, and usually those unconstrained devices have delayed acknowledgements enabled. So that means that acknowledgements may be delayed by typically 200 milliseconds. It could be even up to 500 milliseconds. And if traffic is of transactional type, which is quite common in constrained node networks, that would contribute a necessary delay. So if that's possible at all, disabling delayed acknowledgements would be recommended. For example, that might be possible if the peer is administered by the same entity managing the constrained node network. However, in some scenarios that may not be possible. Yes.
Marko Kojo. I'm just a bit confusing if the traffic is transactional type, and if the server is not responding very slowly, then you don't, the delay doesn't matter at all, because then the acknowledgement comes with the response as piggybacked. So if the server, for example, replies within 200 milliseconds, the delay acknowledgements don't have any meaning.
Yeah, but if you send a data message and that's all, then the acknowledgement will be triggered, will be transmitted by the other endpoint.
Yes, but it's delayed for 200 milliseconds, and if the server sends the response, so data back within 200 milliseconds or whatever is your delay ACK timer, then the response, the ACK comes back with the response. So there is no delay ACK mechanism in such a case.
But you mean if there's piggybacking? But what happens if it is the sensor is the constrained device that's sending a data message? It's expecting an acknowledgement without any data, so it's a pure acknowledgement. In that case, that's just adding some delay, which may or may not be relevant.
That's not transactional. That's kind of unidirectional then.
Well, yeah. So I've seen the transactional terminology used in some places, but well, let's maybe try to clarify the terminology so that it's clear. Thank you. Okay. So another update is in the annex of the document. So if you remember, there's this annex where we are collecting details, the main features of constrained TCP implementations. So now we have other details on the Riot TCP implementation. So this is an implementation designed for class 1 devices. Targets are 8 and 16-bit microcontrollers. The implementation is based on single MSS window. So this simplifies the implementation. And by default, there's only enough memory for a single TCP connection. So at this point, so far, it might seem like Riot TCP implementation is quite similar to micro IP. However, it is not as minimalistic as micro IP because, for example, the memory allocated can be increased to support multiple parallel connections, and then there's an independent buffer provided for each connection. And also retransmission is handled by TCP itself, as opposed to what happens in micro IP, where it is the application developer who needs to take care of retransmissions.
Rahul Jadhav, I beg to differ here. Even in case of UIP, even in case of micro IP, the TCP buffers are handled by the TCP. It's not application who handles it. Only for UDP it works that way. For TCP, it won't work that way because there are other sequence. I've mentioned this in my review comments as well.
Yes.
It's impossible for application to generate the same sequence numbers. The data part, if you're saying, yeah.
Yeah. So I agree with you. And the point is, then the application needs to have some reliability. So the application layer cannot rely on TCP in this case for retransmissions. I agree that you cannot create like the whole TCP segment with the header and so on. So I definitely agree. But that means also that the application cannot rely on TCP for retries in this case.
I just want to make one statement. The current micro IP implementation has multiple connections. Every connection has one buffer, and it handles the retransmissions. So this is what I have already. Yeah.
Okay. So then possibly there's something to clarify about the versions. So also, even if you have input, we would appreciate very much this. Thank you. Okay. Then we have also other details on the OpenWSN TCP implementation, although this subsection is fairly shorter than the previous one. Overall, the idea is that OpenWSN is, according to the details we have received, is mostly equivalent to micro IP implementation. It is really minimal. And as in micro IP, there's a problem with not performing retransmission. So the application developer needs to take care of this. So this is the summary table where we are trying to summarize the main features and mechanisms of the different TCP implementations for constrained devices. So as you can see, we have filled in most of the details for the Riot and OpenWSN implementations. And we have also added the rightmost column for TinyOS. This is currently just a placeholder. So TinyOS has been relevant in several IoT scenarios. So we plan to add details on the TCP implementation of TinyOS as well in future updates of the document. So at this point, the authors understand that the document is quite stable. Also, it is getting more and more complete with the successive updates. So we would like to ask whether this would be a good moment for working group adoption.
Abhijan Bhattacharya. Actually, I have a very generic question. The matter is that...
Closer to the mic.
I have a very generic question. That is, when the WWW, this World Wide Web, that came into picture, then a classical problem emerged for TCP, which is short flow on TCP. And there has been several work that has gone through it. So it is, only a few segments, maybe a few kilobytes of data that has to be transmitted. And one problem that is the slow start and the congestion control that actually that was actually not giving the optimal performance, both in terms of utilizing the increasing bandwidth that the network was offering. So will it be a dimension that also needs to be considered here? Because there has been work like limited transmit and this kind of work. Limited transmit was actually dedicated for, I think it was RFC 3402. So it was very old RFC, but these works were actually for performing these or improving TCP performance for these things. So because I am currently working on something similar to that, and I'm facing some, I had to do the study. So that is what, just a general proposal, whether these dimension can be taken up.
Yes, so
Yeah.
I understand.
So did you read any version of this draft?
Yes, I have.
Me
And
too.
I haven't seen the mention. That is why I'm commenting.
Sorry, good.
Yes, so I understand we can consider this. So in a way, we are considering that, for example, in many applications, there would be a sensor that's going to be maybe trying to send one data message per hour for as long as possible. So that's different from the use case you are explaining. Then I'm wondering if maybe TCP fast open might be a good solution here for the use case you are.
Yeah, I've seen that.
Actually, TFO is in the draft because
Yeah,
of
yeah,
your
that I have seen. That I
suggestion.
have
So
seen.
thanks for that.
Okay.
Almost 1 year ago, I think. And yes, so we can revise the document and see if maybe we can more explicitly refer to those kinds of situations.
Yeah, if possible, yes. I think that will be good.
Okay.
Thank you.
Thank you.
So my name is Michael Scharf. I'm a co-author, but I'm actually speaking here also as TCPM co-chair. I would suggest this working group to adapt the document. It's very clearly understood that work is needed, but I think it's heading into the right direction. I'm not sure if the milestone date that I've seen earlier in the charter is realistic, because at least in TCPM we're a little bit slow with reviews. But in general, I think this should be adapted by this working group.
Okay, good. So any more comments, questions? Okay, so first let me ask, if you have read any version of this draft, please raise your hand. Yeah. Any? So if you think that this, if you are supportive to adopt this draft in Lwig, please raise your hands. Okay. Okay. Hand first. That doesn't, right? Quite a few. Yeah. So if you are not supportive of adoption, please raise your hand. Yeah, no, yeah, no. No. No.
Okay, try your best job.
Oh, yeah, yeah. So it's pretty clear. Yeah, that's, thank you. Next one.
So is it right, more people support adopting than have read the draft?
Yeah, that's normal.
Yeah.
Please use your sticker. Use the sticker.
What's that? Sorry? Oh, yeah. Oh, this. Hello, everyone. I'm Rahul Jadhav from Huawei Technologies. So I'm here to talk about neighbor management policies for 6LoWPAN. So some background. So why is this kind of work actually required? So in case of multi-hop networks, the node density can be anything. It's hard to predict what the node density can be, and the neighbor cache size in case of a constrained node can be really, really small. It can be small even if you can allocate more enough memory. It would be suboptimal. So the point is, node density is high. What to do? The neighbor cache is going to be really small. So how do you prioritize the entries here? How do you prioritize the entries here and ensure the entries that remain in the neighbor cache would result in least churn of the network? So when I say churn, what I mean is that it should be possible to enable proper routing adjacencies such that the network paths don't keep on changing. Now, the reason why this work is important is because if you're playing with 2 or 5 or 10 nodes on a table, till that point everything works out okay. But the moment you go to 50 nodes, 100 nodes, and you have a neighbor table size which is like 10, you're going to have a neighbor management policy in place. So some of the popular implementations. So Riot implements FCFS. Contiki used to implement least recently used entry. So what it does is it just replaces the least recently used entry, and in case of Riot, it populates the whatever comes on the first come first serve basis. The problem is, in case of Ripple based network or in case of multi-hop network, you will have a DIO storm or a DAO storm, and your neighbor cache is going to be populated with the same with all the parent entries, and you won't have any space left for child entries. So there's one typical example mentioned by Joachim on this was mentioned on the mailing list, but from my perspective, I work for a metering solution, and the node density can easily run up to hundreds of nodes in the same vicinity. It's in sub-gigahertz mode, and it can easily cross hundreds of nodes. So how do you manage the neighbor cache entry? So that is what this draft tries to solve the problem. So the considerations here are, it's a security-enabled 6-LoWPAN Ripple network. For the sake of explanation, I've used Ripple as the routing protocol, PANA as the access protocol, and of course neighbor discovery is there. So 3 places where primarily the neighbor table update happens is the initial relay-based signaling. So before the network formation comes into picture, you have to authenticate the node to the network, and that's where PANA comes into picture. Second is the Ripple's parent selection algorithm. Third is when the routing child node advertises itself to the network. Now, there's one thing I have to mention here, that even though I've mentioned PANA because I've used PANA, but the problem is also present in case of 6-tish, where currently there is the PRE element, the PANA relay element is called as a joint proxy there. I mean, the same problem statement exists in 6-tish as well. So these are the terms that are used in case of 6-tish and ANIMA working group. So the neighbor management operation, I'll be real quick here. It's the 3 operations broadly: insertion, eviction, and reinforcement. Insertion, the primary problem with any insertion is you will have. So the way routing protocol works is you have a DIO storm going down, spiraling downwards downstream, and then you have a DAO messaging which comes upwards. So this is how the downstream and the upstream paths are established. So if all the DIO messages are accepted by a child gets like 10 DIOs from 10 different parents, then the table is going to be full in the first place. So there's no space left for the child entries. So how do you handle this case? Eviction, in case of eviction, if you end up evicting a child node entry, it will have a ripple effect on all the other subchilds as well. So it's not very easy to evict a child entry. Well, this is true for storing mode of operation only. But the good news in case of eviction for parent entries is that you can actually evict a non-preferred parent. Now, this I'm using very specific terms to Ripple. All right. So if you evict a non-preferred parent, it is possible to evict it without much implications. And we are going to make use of this particular intelligence in the routing policy, in the neighbor management policy as well. The reinforcement, the link quality estimation has to be updated over a period of time. You can use an active or passive mechanism. Contiki has an active mechanism in the form of active probing of neighbors. Passive mechanism can be you overhear the DIOs or the other messages in the network, and you can update the link estimation. Clearing unused entries. Now, this is also very important because you want to release the neighbor cache entry as soon as possible so that it can be allocated to something else. So in case of storing mode of operation, route invalidation is important because routing entries are directly mapped to the neighbor cache entries. In case of non-storing mode of implementation, you've got to deregister using NS with lifetime of 0, while not many implementations do that currently. And in case of PRE neighbors, there is an interesting question actually. I'm not sure whether 6-tish and ANIMA has a way to handle this, but there is no way currently in PANA to know, for the relay element, to know whether the authentication has been completed, so that it can evict or it can just delete the neighbor cache entry, so that it can be used for something else. So what we propose is a reservation-based policy where few amount of so the reservation is done for routing child entries, the parent entries, and the PRE auth sessions, or otherwise we call it other sessions basically. One good thing about this reservation policy is that if the routing child entries are unavailable or not present, then the parent NCs can still occupy the whole table. Because like I mentioned before, non-preferred parent eviction can be done. So this is what we try to do to optimize the usage of the records in the neighbor cache entry, in the neighbor cache table. The insertion reason needs to be kept as part of the neighbor cache entry because obviously it's going to help in the eviction process. Now, well, whatever mechanism I've mentioned just now is all reactive. What I mean by reactive is that if the table space is actually not available, you send a message. For example, you send a down message, the parent is going to reply back saying that I don't have a space, just check on with some other parent node, and it's going to fail. The problem with this kind of approach is after some time, the same previous parent is going to send this DIO message. And since the child has lost his state information, there's no way for it to know that it can't go through that parent. So in case of Ripple, right now there is no way to know that the table space is all utilized. So as of now, whatever we have mentioned in the draft is all reactive, but it has its limitations. That's what the slide talks about. So in a way, what we want is the parent node to signal in some form to the child node saying that I still have table space available. Now, 6-stitch does this. There's enhanced beacons which has this bit which says that I'm still the joint proxy, I'm still the router, you can connect through me. But this kind of information is missing in the Ripple, and I feel it might be useful there as well. So this is what I mean by the proactive way. But having said that, this is clearly out of scope for Lwig, and we would like to bring it to the role working group or 6-law working group for discussion.
So if it was purely, I'm Michael Richardson. Yeah, I'm Michael Richardson. So if it was purely implementation advice, then of course it would be I was going to say, is there any protocol action here? And I actually think that my advice is maybe this, I want to say that maybe this belongs somehow in neighbor discovery messages. And yet, we can run Ripple networks, as Karsten hates, without ever actually doing router advertisements. And so because it really matters to leaf nodes, right, that they hear several router advertisements, that they better pick one that actually has space in its neighbor cache for it. And it really matters for new joining nodes. So it would be really nice if that was actually at that level too. And maybe we have to put it in both in the DIO and in the router advertisement. I don't know if Karsten has an opinion about where it goes, but I mean, there's a protocol action here about this. And if you pick wrong, then poor little unpowered devices that turn on once a week are screwed because they're never LRU'd into the cache.
So it's not only about Ripple and 6-law here. So in case of key management protocol, there's PANA involved as well. So PANA discovery involved.
Just a moment. So Michael asked me specifically whether I have an opinion. I do have an opinion. If it's for hosts, it goes into ND. If it's for routers, it can go into ND, or it can go into the routing protocol.
Both needed.
Well, okay. Well, if it's needed by both, then it's clearly a neighbor discovery because neighbor discovery is received by both.
So Karsten, can I ask you two questions? First, could you keep your comments related to do you have any comments related to the reactive way Rahul just discussed? And the second question is also related. So for the proactive way, which working group is the best place to discuss? I definitely not here.
I understood Michael's question essentially as trying to decide between role and 6-law. And given that 6-law is working on neighbor discovery, to me it seems that this is something we should fix in the 6.7.7.5 update process that is going on in the 6LoW.
Yeah. But here today, I really want to listen. What's your comments to the reactive way, which is definitely within the scope, the charter of Lwig?
Well, advice is also always very good. I mean, even if
closer to Mike, please.
Even if 6LoW has done the work, it's probably still good to have a document that explains how you use it. I mean, if this is all explained in wonderful detail in 6775 bis, yeah, but I think it's better to have a document that actually reflects implementation experience and so on. So I think this is a useful document to have.
Okay, great.
Yeah, Michael Richardson again. I think I would agree. So I would suggest all of the advice, okay, in this document be there. It maybe needs to update 6775. Okay. I don't know. Let's take that to the list, maybe. Yeah. But that the proposal for the additional metrics that we need should be a new document in 6LoW, and or a proposed text to 65775 bis.
It should be a working group last call comment on 6775 bis.
Yeah. So our rationale was, we keep this draft here. We specify the requirements towards all the changes, and then we take on the actual changes in the specific working groups.
Yeah, quickly. Yeah.
Right. Yeah. I'll do it.
Okay, let's quickly ask how many people have read this draft? Any version of this draft? I think there's only one version. Okay. So like 5. So how many of you think that we should? Oh, sorry, it's not a question. So if you think that we should adopt this document in Lwig, please raise your hand. You did. So if you think that we should adopt this document, focusing on the React, okay. Again. So, okay. So how many? So if you don't think that we should adopt this document, please raise your hands. No. Okay. Pretty clear.
All right. So, thank you.
Okay,
thank you, Omar.
Let's move to the next one.
Hello? Can you hear me? Okay. Hi. So I'm here to present a bit more of a research work. It's not really an IETF document. What I'm presenting here, it's about an implementation we did on a group IKE client. The group IKE is another draft which is going to be standardized, I guess, quite soon. The authors are here. So yeah. So the motivation of doing this work was kind of because we didn't find any useful group key management protocol which is deployed in IoT. I know of one in DTLS which was going to be standardized, but or in ACE. That was kind of the motivation to start this research.
Just a question. The DICE work, the DTLS stuff, it was actually done in a separate working group, and then we decided to abandon it because it made changes to the DTLS that people didn't want. This document is not not your document.
This is the group IKE document,
right.
Like the standard group IKE, not the minimal.
But have you written a document on your stuff as well?
No.
Okay.
That's what I'm saying. Okay, so I just quickly want to tell you, like, this is also a follow-up on minimal IKE because it's pretty much correlated. So what group IKE does, so the first exchange is setting up a secret channel between client and server. This is completely standard IKE, and it's also minimal IKE. So minimal IKE really helped in this implementation. The second part is actually just to request the secure keys from the group server, which is also mostly the same as the IKE SA, the IKE auth in IKE v2. It's just that you don't negotiate a key because you get it from the server. That's the main difference. So you ask for a group key and you get one. It's not a negotiation of a key. And the rekeying is basically the same. We implemented this in Riot. we figured out that we need around 6 kilobyte of memory to run this, including the the ciphers to be stored for then actually doing group message, like securing group messages, for example, with ESP or 802.15.4 or whatever. And we tested this on 3 different devices, which are 3 Arduinos. So it works on every M0 device, which has the ARM M0 in it.
Michael Richardson, so to be clear, you need 6 kilobytes to get to the end of the process, at which you have 40 bytes for the SPD left, and that's all you need to keep afterwards.
What? Sorry. Okay.
Sorry. So you need 6K to do the whole time sequence you just described.
No,
right?
That's the whole memory we need for the system in RIDE. There's the RIDE kernel included. There's the IPv6 class.
Oh, okay. Well, no, I don't mean dump the kernel. I don't mean that. I'm trying to understand how much of the pieces that you accounted for persist after the so the IKE SA and the bottom thing. So, okay, thank you.
And yeah, we run this code against the only implementation we found, which is a Cisco router. The results, I think, are pretty good. The big chart here is the Diffie-Hellman with elliptic curves. I forgot to mention that. So the crypto we use is AES for the encryption, the HMAX for integrity and PRF, and for Diffie-Hellman we use a elliptic curve.
That's what I was wondering, which is missing in the table above, and it relates to the comment that Michael had, or a question Michael had, because if you use a Diffie-Hellman, you need the big num library. That typically will, if you want to have any reasonable performance, that will require a fair amount of RAM, which is only temporarily, but it needs to be there, otherwise the stuff will not end. That's sort of missing, so you need, that's why the 32 kilobyte RAM device was able to handle this, but for example, if I remember the numbers correctly, there was about 10 kilobyte for reasonable RAM for reasonable protocol run with elliptic curve cryptography.
I don't.
If you want to optimize the point computation, I have to look up the numbers, but I think you have to take that into account as well in the estimate. Yeah, but the RAM numbers don't show that.
I think that's part of the kernel, right? No, okay.
Okay, let's take this to the list.
Yeah. So yeah, that's what we did. So, and what I want, so this thing only happens once at the beginning of the session. So yeah, that's reasonable amount of time, I guess, for establishing a group communication. So yeah, what could we do for minimalization for this? I think pretty much everything is done by minimal IKE already, except that there is a bit of modification from the IKE auth to the GSA auth and the GSA rekey, just because it has another meaning here. And what would be also helpful to have recommendations on like how to configure the server so that the actual group SA auth message is kind of minimal as well. So yeah, the question, so we have an implementation available for RIDE-OS. I know that there is an implementation, or I heard that there is an implementation for Contiki, which is going to be released soon. I've not seen it. And yeah, the basic question is there interest in the working group to do this kind of work here, or?
Cosmo, I'm trying to understand when I would use this. So this is essentially, I open a secure channel to a server.
Yeah.
And then I do a get on a key.
Yeah.
I know how to do that today.
Yeah. Yeah.
Yeah.
Mike, because we are running out of time. So if you have technical questions, I suggest you bring to the list. If you have.
Yeah, we can discuss the technical discussions on this.
So I wish you had come earlier, because we actually have work ongoing on group communications security in the ACE working group, an extremely painful process. And we are if you could have implemented that one, it would have been such a great sort of benefit for the community. And unfortunately, you went for the wrong thing. I think for a couple of reasons. The first one is it refers to a document that apparently is an individual document. I don't know what the status of that other document is, whether that will actually be adopted in the IETF. And then the minimum IC actually doesn't do you a favor here. If you look at the discussion that we had in ACE, there's a fair amount of interest to also add the authorization capabilities and to add public key cryptography to the whole equation to make it resistance against certain attacks. But you can answer probably the first.
Yeah, the last comments. Yeah, we can.
Okay. Brian Wise answering the first question. So the other draft is still being formed. There is at least one implementation, commercial implementation. I'm sorry. Yeah, we the authors are would like to take this through IPsec-ME, but we haven't asked we haven't been ready yet to ask the chair yet. So that's but there's definitely implications. This is a thing that's happening now. I would say it's probably a little.
Tara, no more comments. No more
not for
comments.
IoT particularly, but I would say that. So I would say it's
been,
probably a little too early to be asking. If this working group's interested in a minimal version of that, but
the meeting
I think it's a feasible.
So the line is cut. Tero, if you want to make a short point, take like 8 seconds.
Okay, so the draft has been there for a long time. It was MSEC first, and MSEC shut down, and that's why it get left orphan. And I think there is an AD support for that, so it should go through as an individual draft, or we can go to the IPsec-ME.
Thank you all. Go and enjoy your evening.
Thank you.
Yeah, no problem.
Do you have time for a drink after the goodbye? No.
No, I'm not going to bits and bits.
Yeah,
I have dinner plans here.
So it's you are a great postmaster yesterday.
Yeah. Thank you.
So why Alyssa is not here?
She's having a baby.
Oh, congratulations.